Okay, here's an introduction to Matlab. What you're looking at is the interface of Matlab. Here we have the command window. So Matlab is a programming language, which means you're interacting with the computer, tell them what to do, and they'll do those things for you. So the command window is where you interact with Matlab, tell it what you want. So for example, I'm going to enter x equal to 1. That says I'm going to assign the value 1, the number 1, to a variable named x. So it's variable name equal sign value. And when I press enter, then Matlab executes that command and assigns the value 1 to x, which shows up in the workspace. The workspace is working memory of Matlab. So once I assign a value there, then it gets stored in Matlab so that if later on I need to use that variable, let's press X, let's enter X in the command window, then Matlab tells me that X is currently equal to 1, for example. And one thing to pay attention to is I can reuse that variable name and assign a new value to it. So for example, if I do x equal to 2, but then that immediately erases the value 1 that was stored in it, and that value 1 will not be retrieved later. Now x is equal to 2, so if I press S, then x is equal to 2 in the working memory. So once you assign a new value to a variable, it updates the value of that variable. So let me now clear the command window by the command CLC. That clears up the command window. And if I want Matlab to forget the variable x and delete it from the memory, then I use clear x, and you can see that it's deleted. So I press X again, then Matlab says undefined functional variable x because it's not in the working memory and Matlab don't know what it is. So now let me tell you a little bit more about the commands. The basic type of commands we're going to begin with are those that says variable name equal to calculation or value, like the one we saw before. So let's retype that. X equal to 1 is a basic type of command. And you need to pay attention to what is to the left of the equal sign and what's to the right of the equal sign. Again, what this means is that I am assigning something from the right-hand side of the expression to the variable name that's on the left-hand side of the expression. Matlab is picky about the variable name. So for example, if I say x sub 4 and I type x space 4, you immediately recognize that this 4 is now no longer in black and it's in purple, so there is a problem there. And I say x4 is equal to 2, then that returns as an error because Matlab does not allow space between different letters or numbers in a variable name. So now it's interpreting it as differently. So if I really want x sub 4 equal to 2, I can do x4 equal to 2 or x underscore 4 equal to 2. So a good practice for choosing a variable name is a name that makes sense. For example, I'm going to create a matrix in Matlab and assign that to variable name matrix A. So I'm going to type matrix A equal to a matrix 1, 2, semicolon. So that tells me 1, 2 is the first row, and then 3, 4 as the second row. Close it with a bracket, and then execute that command. So that assigns the matrix 1, 2, 3, 4 to the variable name matrix A. Or I can use matrix underscore A. That clearly indicates what you are assigning here, and it's easier for you to read once your code gets very long. Okay, next I'm going to show you a slightly more complicated command, which is assigning a simple calculation to a variable. So I'm going to let size of matrix A equal to the size of the matrix. So to retrieve the size of that matrix A we just defined, I can use the MATLAB function called size. So the syntax is function name parameter, function name parenthesis, input of the function. So size of matrix A, close it with a parenthesis that says I want to extract the size of that matrix. And as we remember, the size of a matrix has two numbers. The first is the number of rows, the second is the number of columns. So when I assign this right-hand side expression, which says give me the size of this matrix, to the left-hand side of this expression, which is this variable name, then it assigns this and these information, which is stored in a vector, to this variable size of matrix A. So if I want to retrieve size of matrix A from Matlab, then it tells me it is 2, 2. And so you can retrieve the number of rows in A is equal to the first entry in the vector. So size of matrix A parenthesis 1 tells you I want to get the first entry of this vector size of matrix A, which is the number of rows in matrix A. So let me give you a few more examples. We can add two matrices. So right now I have two matrices. One is matrix A, one is matrix underscore A. Those are two different variable names and they store different matrices. And I'm gonna add those matrices and I'm gonna store the calculation result in a variable name. Let's just say result. Result is equal to matrix A plus matrix underscore A. And that is the resulting matrix. You can see that matrix addition is done entry-wise. And this addition is only well-defined because those two matrices are of the same size. So if you have a different matrix, say matrix B, that is a different size, 1, 2, 3, 3, 4, 5, and you try to add them. So let's say result 1 is matrix A plus matrix B, then what do you expect? The sum is not well defined, so Matlab gives you an error that says matrix dimensions must agree. Matrix dimensions here just means matrix sizes. That's the same concept. So soon you find yourself with a lot of commands in the command window, but you actually want to record what you just did and sometimes maybe execute a few commands at the same time, what we would call a script. So what I'm going to do here is, look what I just did. I clicked on the button that says New Script and open up an editor. So the editor, so the command window has shrinked over here. And the editor is where you store a few commands in one file. So for example, what I just did, let's copy from the command window. Let's have matrix A, where did I define it? Matrix A equal to 1, 2, 3, 4. Let me copy that over here. And then matrix underscore A is 2, 4, 8, 9. So Matlab distinguishes between commands by looking at, by having them in different lines. So if these are two different commands, they need to be in two different lines. And the order they're executed depends on the line number. So this command is going to be executed before that command when you execute this entire script. And I can put a third command here. Let's say I want to size a matrix A right here, matrix underscore A, and I'm going to have matrix A plus matrix underscore A stored in results. And right here in the command window, I'm going to clear all the variables. So I'm going to use clear all. See that everything in the workspace just disappeared. If I type who, Matlab, which tells me who is in the workspace, and Matlab says nobody is in the workspace. I can use CLC if I want. Actually, before I do that, let me just get matrix B right here real quick. and I'm gonna type CLC, press enter, and that clears up the command window and that gets cluttered. So here what we have here is a few commands written in separate lines, line by line. And if I save that as a file, let's say I am in the folder lab 1, I'm going to save that as introduction, sorry, not introduction, introduction.m. See, the format is .m, that means it's a Matlab code file, and you click save. Then you find this file right here in the editor. That is the file you just saved. And the way to execute this script or execute all the commands all at once or run the script is by clicking this run button. So if I click this button, then MATLAB just executed all the commands all at once, and you see it created these matrices, and it calculated what's this result according to this command line. And you can see it did it line by line. See, first matrix A, then matrix underscore A, then size of matrix underscore A, etc. And within the script, if you ever want to suppress a printout, let me show you what that means. If I put a semicolon here, a semicolon here, semicolon here, then these commands are not gonna, the results of these commands are not gonna be shown. So right here I have 3 commands whose printouts are suppressed and only 2 commands who I want printouts. And if I click run again, then this is not very clear. Let me clear the command window first. And I click run again, then you see that it only print out the results for these 2 lines right here and not the first 3. So that's about the semicolon and the M file editor and how MATLAB executes commands in an M file editor. So the next thing I want to talk about is the percentage sign. Here's the percentage sign. You can see it's shown in green. This is the sign that MATLAB uses to tell the computer that whatever follows the percentage sign is a comment, not a command, and therefore is skipped during execution. So for example, I'm going to say this command finds the size of matrix underscore A. Then during the run, this does not do anything because it's skipped. And this is helpful because as a programmer, sometimes you want to know what these commands are doing. So these are notes to yourself or to others who read your code, maybe your coworker or your boss or whoever needs to use the code you wrote, and this will be very helpful. The comment can be after the command or in a new line, it doesn't matter. Okay, the next thing I want to talk about is the first line of your M file, which is recommended to be clear all, close all, semicolon, CLC. What that does is remember, because MATLAB executes line by line, so when you run this M file, it starts with the first line. Clear all clears all the variables in the workspace. Close all closes all the printout figures. We don't have that yet, but it will be helpful later. CLC clears out the command window. So if you execute those 3 commands first, then it gives you a clean slate to begin with. The reason you want to do that is, for example, if you have other things already in the workspace. So if I say I already have matrix A that is 1, 0, 1, 9, 2, 3. Okay, that's already in the workspace. And then I go on and work on this command, and I have result is equal to matrix A plus matrix underscore A. But the matrix A I had in mind was here because I saw what I defined. which might not be the way because you made a mistake or something, and is now a different matrix. And now if you execute that line by evaluate selection, did you mean, oh yeah, and now let me execute that. So I have matrix underscore A, and I execute that. Then the matrix A, when you execute this command, is gonna be this matrix A. I'm sorry, not, it's gonna be this matrix A, and not this matrix A you had in mind. So because sometimes we reuse variable names, etc., it's always good to start with a clean slate right here. And for the same reason, if you have a variable that you need in a later command that you thought was defined but find out it was not because Matlab gave you this error, undefined functional variable, then you know that you need to go back there and execute another command in the previous part of the file. Okay, we're almost there, but I want to go. Next thing I want to show you is a different use of the percentage sign. This is not just about a comment. If I use double percentage sign, you see that what happened is this part got highlighted in yellow, and there is a line that breaks this part from the previous comment. What happens is the double percentage sign breaks the M file into different cells. I think those are called cells, or you can understand them as different sections. And what happens is you can now work on individual different parts of the file without without running the whole file altogether. So for example, if I press Control Enter in Windows and Command Enter in Mac, then it executes only these commands within this section that's highlighted. Or you can use right-click, evaluate current section, then that's what gets evaluated here. And that can be, completely different from the section you're working here. Which brings me to the topic that I really want to talk to you about, which is about the labs in this course. So right here, I already wrote a file, prepared that for the lab, which we can open here in the current folder. Current folder is kind of like Finder in Matlab or My Computer in PC, which is a directory for the hard disk. So the file I already stored in the directory week 1 intro matrices. I can open that, and I have written that in terms of sections. So the first section is all comments, just telling you about the instructions, and then I have examples and exercises, and I've broken them into different sections because sometimes they are just individual problems. The reason I do that is I want a convenient way for you to complete exercises and read examples within one file, so not in a million different files that you have to find. And so one thing you need to know is here, for example, I define matrix A. So as you read through that, what you want to do is, if you're in Mac, Command Enter, and to execute that command, or if you in Windows, Control Enter, so that this is stored, this matrix is stored in the workspace, so that later on in exercises you can use it. And what I want you to do is to go through these section by section, understand what I was talking about in those examples, and then execute the sections as you go along. And then when you go into an exercise, for example, here, I want you to create a matrix. Then in the example, I've already shown you how to create a matrix. So here, for example, let's say the matrix you want to create is this matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, then I said create this matrix and then stored it under the variable name matrix I. So I specified a variable name, then that's the variable name you should use. So what you do is matrix I is equal to this matrix. So variable name, again, equal sign, and then the command that does the assigning of does the creation of the variables or the calculation that you want to do. And do not put a semicolon because eventually I want you to print out those results. So let's pick another example. Exercise 2, the size of the matrix. I say to find the size of matrix B and store it under this variable name. So do we have matrix B here? Let's say matrix B. Oh, hold on, sorry, one sec. Okay, I just stopped to have a conversation with someone and I don't remember what I was talking about before, but I think I was talking about this set, another example of how you want to do the exercise, and I was saying, again, you want to find the size of matrix B. Oh yeah, so I was talking about you first need matrix B. Excuse me, matrix B. So supposedly, excuse me, you've already executed the command in this cell to define matrix B, and then you go back to exercise 2, where you want the size of matrix B, and you want to store that in a variable name. So that's the calculation, that's the equal sign. Variable name is to the left, which is, I specified I want to name size of matrix B. So just choose that, copy that, and right here. So that is variable equal to what it should be, and execute that, and it tells you what is the size of matrix B. And one note is you do not need to copy the printout from the command signs into these. All you need are if it's a Matlab syntax I want, then you just need a Matlab command right here. Unless it is a word answer. So for example, here, exercise 0, I said, what does the command Y tell you? So you just type Y in the command sign. It gives you a result. And this is the case when I want you to say, copy the, I would specify copy the answer, and then you just copy the answer right here. And it's a word answer, so it's after this percentage sign. Okay, so let me show you why I want you to do this and why I specify you should not put a semicolon here. There is a very handy function in Matlab called publishing. So if you click on this tab, publish, right here, and then click on this button right here that says publish, it publishes the current M file into an HTML file. That is very nice. So the reason I've been using these double percentage to break it down into different sections is because I want different sections here. So for example, this first section is just instructions, and the two exercises we just saw, the size of matrix is right here, exercise 2. And let me scroll down to the corresponding M file so you can see how this is done. In exercise 2, you put in this command. That's the only, that's what I was asking for in your lab exercise. And correspondingly, when you publish it, what it does is it is adding this part to your HTML file. So when I did not have this was what the file was before, right? When I gave it to you and you published, then under exercise 2, all you had was the problem description I gave you. So I say, here's exercise 2, number 1, find the size of matrix B. Number 2, find the number of rows in matrix B. But once you enter the answer, the command, then when Matlab publishes, it takes this command, runs it in Matlab, and it publishes both the command and the results, as long as you do not have a semicolon here. So it puts the command in the gray box and the results in as a printout. So this way, both you and I can look at what you did and what result that was in Matlab in a very clear, nice way. This function is very handy when you need to share your file with someone, so with your coworkers, etc., so that you want to tell people what you just did and then show them the command you used to do that, and sometimes even the results. So with these, it's just a way of, you can think of it as a notebook where I wrote down, here's a different, a bold font where I highlight the title, section title, and here's what happens in this section. Let me see if I missed anything. So another example here, exercise 4, I wanted to calculate the matrix product matrix B times matrix A, and like I said in exercise 3, A is interpreted as the matrix stored in matrix A, B is interpreted as the matrix stored in matrix B, matrix A variable, matrix B variable. And in an example, I already calculated what is matrix A times matrix B, and I stored it in the variable name A times B. So if you execute that cell, this is what you find. And here I'm asking you to find the product B times A. So you can use any kind of variable name here. You can use results equal to matrix B times matrix A, and that gives you matrix B times matrix A. Or you can say B times A is equal to this, then it tells you B times A is equal to this. As long as you have a legit, if I don't specify the variable name, as long as you have a legit variable name, it's fine. Then next thing I ask is A times B equal to B times A? So what was A times B? A times B was this matrix. B times A was this matrix. So the point I'm making here is that matrix multiplication is not commutative. This operation does not commute, which means it matters which way are you multiplying those two matrices. A times B is not, in general, not equal to B times A. And for this lab, what I ask you to do is to write your word answer here. So first you find the products right here, and then you see that it's, and you type whatever answer you want. Say AB is not equal to B times A for these two matrices, for example, and that will be your answer. So in the end, your lab report consists of this end file when you complete all these sections in the exercises. And in each section, you should have sometimes Matlab commands and sometimes word answers like these. But you should not copy these things unless it's something I wanted you to put in a comment. And another thing you might be confused about is this right here. This is a LaTeX syntax. The reason I'm using this is I want a nice expression in the published file. So exercise 5, I'm going to show you what was exercise 5. In the HTML that's published, this command right here, this line right here, is what produced this matrix here. So Matlab also interacts very nicely with LaTeX in publishing. And so when you're looking at the problem instruction for this exercise, it's probably more helpful if you just look at the PDF I provided you. For the other instructions, it's the same. You're just reading those English words. But for this one, it's much nicer if you can just look at the PDF where you can say here. So for example, in part B, I want you to calculate p squared and store that into the variable p underscore squared. So you're calculating matrix p times matrix p, and then storing that in this variable. All right, and that might be confusing if you're just looking at the LaTeX I was writing, but it's much more clear. So it's much more clear if you look at the PDF. So this is not what you want to do in Matlab. This is not Matlab syntax. This is LaTeX syntax. So in the end, you want to hand in the M file and the published file. I want the published file in PDF. So once you generate the HTML, press Control P, and it's gonna save as PDF, and it will give you a PDF. All right, and now I want you to submit that through Moodle. I think I got everything. If you have any questions, ask me. Okay.